Hello everybody, we're getting ready to do Chapter 7 Part 2 SAT Math Level 2 Preparation. And for Part 2 Chapter 7 you got 12 points in your notebook and 14 points will go onto your classwork sheet. Name date period in my class, due date here for onliners, homeschoolers. And for the first slide here, in a circle of radius r, here's radius r here, inches with an arc subtended by a central angle of theta. Here's central angle here. Here's S, which is our arc. Measured in radians, two important formulas can be derived. The length of the arc, S, is equal to r theta, r times theta, and the area of the sector AOB here is equal to 1/2 r squared theta. So knowing that, we'll jump right into a situation. J here, find the area of the sector and the length of the arc subtended by a central angle of 2 pi over 3. Radians in a circle whose radius is 6 inches. So using our formula, S equals r theta, area equals 1/2 r squared theta. So in this case here, S equals 6 times 2 pi over 3, which would equal 4 pi inches, would equal S, so we know the length of our arc. So the area would equal 1/2 times 36 times 2 pi theta, so 2 pi theta, which is here, 2 pi over 3, which would equal theta. Multiply this out, we get 12 pi square inches is how we find that. R squared is 36. So now K in this situation, in a circle of radius 8 inches, find the area of the sector whose arc length is 6 pi inches. So again, we're using S equals r theta. Our area equals 1/2 r squared theta. So 6 pi here equals 8 times theta in this situation here. 6 pi inches equals 8 theta. And then we plug in here, area therefore will equal 1/2 times 64 times 3 pi over 4 will come out to equal 24 pi square inches. Okay, so here for L, find the length of the radius of a circle in which a central angle of 60 degrees subtends an arc length of 8 pi inches. So the 60 degree angle must be converted to radians. So 60 degrees equals 60 times pi over 180 radians, which will come out to pi over 3 radians. Therefore, S equals r theta. 8 pi equals r times pi over 3, which would come out to being 24 inches here in this case here. Analyzing the graph of a trigonometric function can be readily accomplished with the aid of a graphing calculator. Such an analysis can determine the amplitude, maximum, minimum, and period, or phase shift of a trig function, or solve a trig equation or inequality. The example and exercises in this chapter show how a variety of trig problems can be solved without using a graphing calculator. They also explain how to solve trig equations and inequalities and how to analyze inverse trig functions. Since the values of all trigonometric functions repeat themselves at regular intervals, and for some number p, f of x will equal f of x plus p for all numbers x, these functions are periodic trigonometric functions. Since the values of all trig functions repeat themselves at regular intervals, and for some number p, f of x equals f of x plus p for all numbers x, these functions are called periodic functions. The smallest positive value of p for which this property holds is called the period of the function. The sine, cosine, secant, and cosecant have periods of 2 pi, and the tangent and cotangent have periods of pi. The periods of the 6 trigonometric functions shown below demonstrate that the tangent and cotangent repeat on intervals of length pi, and that the others repeat on intervals of length 2 pi. The domain and range of each of the 6 trigonometric functions is below. So here's our summarization of parent trig functions. So for the domain, we're going to list domain and range of sine and cosine negative infinity, infinity. Then your range would be negative less than or equal to sine x less than or equal to 1. Cosine would be negative infinity and infinity for your domain. Your range would be negative 1 less than equal to cosine x less than or equal to 1. And then the tangent would be all real numbers except odd multiples of pi over 2. And then your range here would be all reals. And then cotan would be all real numbers except all multiples of pi. And then your range would be all real numbers. Then secant would be all real numbers except odd multiples of pi over 2. And then here is your range here would be negative infinity, negative 1, in union with 1 and infinity. And then cosecant would be all real numbers except all multiples of pi would be in your domain of the cosecant function. And then negative infinity to negative 1 here, and then union of 1 and infinity. Trig functions can be transformed just like any other function. They can be translated or slid horizontally or vertically, or dilated, stretched or shrunk horizontally or vertically. The general form of a trigonometric function is y equals a times trig, bx plus c plus d, where trig stands for sine, cosine, tan, cosecant, secant, or cotan. The parameters a and d up here, a and d, accomplish vertical translation and dilation, while b and c accomplish horizontal translation and dilation. When working with trig functions, the vertical dilation results in the amplitude, whose value is absolute value a. If b is factored out of bx plus c, we get b times x plus c over b. The horizontal translation is negative c over b and is called phase shift. And the horizontal dilation of trig functions is measured as the period, which is the period of the parent trig function divided by b. Finally, d is the amount of translation. So if this sounds strange to you and you need review, get some of my review packets. Here is sine x is an odd function, so here's an example here of a sine function, y equals sine x. And then here's y equals cosine x. Cosine x is an even function. Cosine x is an even. And then here's your y equals tan x function, and then y equals cotan. So pi 2 here, this is where it intersects the well, anyway, if you need review of your trig, get a hold of me for trig packets. And then here's our cosecant, y equals cosecant x, and it goes like this here. Here's your vertical asymptotes here of your cosecant, and then here's your secant function. Again, here's your vertical asymptotes here, multiples of pi over 2. And okay, so let's go into an example here. Example M, determine the amplitude, period, and phase shift of y equals 2 times sine 2x, and sketch at least one period of the graph. So a equals 2, b equals 2 up here, b equals 2, c equals 0, d equals 0. So amplitude in this case will equal 2. And then our period will be 2 pi over 2, which would equal pi. Phase shift is 0. Vertical translation 0. And then since the phase shift is 0, the sine graph starts at its normal position here at the origin 0, 0, and is drawn out to the right and to the left. Here we go, here like this, and then down here like that. Y equals 2 sine 2x. Then we're going to go into and here determine the amplitude, period, and phase shift of y equals 1/2 cosine of 1/2 x minus pi over 3, and sketch at least one period of the graph. So here this is broken up into pi over 3's because of this element there. Although a graphing calculator can be used to determine the amplitude, period, and phase shift of a periodic function, it may be more efficient to derive them directly from the equation. So a equals 1/2, b equals 1/2, a equals 1/2, b equals 1/2, c equals negative pi over 3, and then our d here will equal 0. So that would be our vertical translation. So amplitude is 1/2, period is 2 pi over 1/2, which will equal 4 pi. And then our phase shift, be pi over 3 over 1/2, will equal 2 pi over 3. Knowing that, we can therefore graph that thing. Since the phase shift is 2 pi over 3, the cosine graph starts at x equals 2 pi over 3, which would be there, instead of x equals 0. So here's 2 pi over 3. That would be our phase shift. And then one period ends at 2 pi over 3 plus 4 pi, or 14 pi over 3. So here is your period ending there, starts there, goes up over here, and then that would be one full period there. Determine the amplitude, period, and phase shift of y equals negative 2 sine of pi x plus 3 pi, and sketch at least one period of the graph. So here again, a equals negative 2, b equals pi, c equals 3 pi, and d would equal 0. So amplitude in this case will equal 2. Our period would equal 2 pi over pi, which would equal 2. Phase shift would equal negative 3 pi over pi, would equal negative 3. And then since the phase shift is negative 3, the sine graph starts at x equals negative 3 over here, negative 3 over here, instead of x equals 0. And one period ends at negative 3 plus 2, or negative 1. So right here would be the end of one period here. The graph can continue to the right and to the left for periods as desired. Since the coefficient of the sine is negative, the graph starts down as x increases from negative 3 instead of up as a normal sine graph does. So the coefficient of the sine is negative. And that was Chapter 7, Part 2, SAT, Math Level 2 Prep. Animated PowerPoint, mathvideo@aol.com for course materials or questions. Thank you very much.